क्षेत्रावर आपल्याला विजेची टंचाई भासणार आहे. तर आता सध्या आपण कन्व्हेन्शनल बेसिसवर वीज हे करतो, प्रोड्यूस करतो, पण नॉन कन्व्हेन्शनल बेसिसवर सोलर ही मेजर सोर्स आहे. पण ती ग्राउंड बेस सोलर पॉवर आहे ती नॉर्मली 7 to 8 आवर्स आपल्याला अवेलेबल होते. पण स्पेसमध्ये इनॉर्मस पॉवर आहे सोलर पॉवर. त्या बेसिसवर मी पुस्तक लिहिलेलं आहे आणि नासामध्ये आणि जाक्सा म्हणजे जपानमध्ये त्याचं रिसर्च पण चाललेलं आहे. मी पुस्तक लिहिलेलं आहे. मी PA कुलकर्णी साहेबांना प्रेझेंट केलं.
पुस्तकाचं शीर्षक आहे स्पेस बेस्ड सोलर पॉवर बाय NR सोनकवडे. दोन शब्द.
Solar power systems can supply clean, calm, and stable electric power.
We are Autonomous Body and the Department of Space, and let me tell you, our institution was set up in 2007 with the basic intention to create a quality human resource. So, here we have three disciplines are there: aerospace, avionics, and physical science. Physical science, we teach them more physics, atmospheric science, geology, plus mathematics, and so on and so forth, astronomy. In avionics, we teach them electronics, electrical engineering, plus control systems and other. So it's a combination of electrical engineering, electronics and communication, and computer science in some sense. Aerospace, where we teach more aerospace and mechanical engineering. And the purpose of this institute is that every year we take 156 acres of land to a we give them scholarship, and if they qualify, currently before 2013, if they get a 6.5 CGPA or higher, they will be joining ISRO in different centers. So we work in close collaboration with ISRO different centers. Okay, and ISRO has different centers, like one in Bangalore, one in Ahmedabad, and there are three centers. There are two centers here. One is NPSC, which is our neighbor. Then Vikram Sarabhai Space Center is there, which is in the city near the airport. And then we have one in Mahendagiri, which is another new center has come up. Plus we have in Hyderabad, there is a Remote Center. Then we have in what is called in Bangalore, we have a satellite center where they manufacture the satellite, and all the payloads come from different places like Ahmedabad and other places. The launching takes place on the Shah. So this way, so basically this particular institute has been built in order to create a quality manpower so that they can join ISRO and they are ready to enter into all the research things from the day one. So we have started in 2007, so basically 2007 batch has joined ISRO, 2008, 2009 and 2010 is just in the queue. May, June they will be placement will take place. They join in different sectors of ISRO, depending on their choice, depending upon the requirement. Plus, we have postgraduate degrees and tech in 13 disciplines. We have some is floated from avionics, some by aerospace, some from physical science, some from physics, and some from mathematics. Okay, and then we have a PhD program. We have around 81 PhD students, and we already 3 of them got the PhD degree, and somebody is submitted, and somebody is submitting the research. So this is an academic institute where there is an undergraduate program, there is a postgraduate program, and there is a strong research body, such that we can take up some of the challenges of ISRO and try to do something such that it can give some input. It could be in terms of analysis, it could be in terms of design. This is the basic premise on which this center is there. And in addition to that, we have a program. Students are trying to launch a satellite. They are trying to design a rocket, which this is the first time in India our students designed what is called VM1 and now VM2. So this is the ambience. Okay, and we are very keen to participate or work in this sort of solar power system, but it's a long drawn process. So as a first step to that, they are trying to come up with material, trying to increase the efficiency, trying to see the intellectual part or the academic part such that they as a faculty can get the benefit of producing PhD plus their good publications, so on and so forth. So this is the first requirement. Second thing is that if a solar space-based solar power is to be done, then it is not only the job of this institute, because this institute has got maximum maybe 300, maybe 400 people, but that is not the each center has to contribute, and nationally as well as internationally. So there should be a big big infrastructure to do that. We can act as one of the players in that. Okay, maybe a small player, maybe a player who can contribute in the thinking process and so on and so forth, right? And there should be other players also. So this is the present situation. So they are very keen because all of their discipline, you see, he is an expert in power electronics, so he knows how to develop electronics. He is a device expert. She is a material science expert. So that way we can come up with some synergy and try to develop something. But the point now here is that you have a wishful thinking, and we have a plan to develop certain intellectual. But how to merge this? Some glue is required. Now, who can be a glue? It should be a very bigger than any one of us, right? So I have a feeling we should meet Abdul Kalam and tell him, sir, this is the book I have done, and you create and let us see how. And he is a person of tremendous energy, tremendous motivation, and he can really though he has got very very bright ideas, and he is very passionate about this. Okay, so all these things, if you take into account, then you have to meet him someday, sometime, and which you do in a particular way. And if this has to be done, then there should be something from your state also, because you are representing the state electricity board, and what will be the stand of state electricity? Because each of us has no identity unless we are at an institute. All of them are very bright in their academic career, but now they are part of affiliated to IIST, so they have a strength. We have a collective institution. Like that, you may have to find out that what is the view of your department, because ultimately that is your parent organization, and parent organization has parents are always larger say than anybody else, right? Like for me, I cannot do anything unless Department of Space says something. Similarly, you also have to do things. So I really appreciate your effort and your motivation and your some sort of drive in making this book. It's not an easy task. But now, if you have to go one step beyond, you have to put more energy now. First level is done. So you have to have more energy, and in order to get that energy, you need certain catalyst, and you have to get the catalyst. This is the bottom line. And they have told you what they want to do, but they are doing is more from an academic, very humble, very small scale requirement, and there they want to get into the international research area. They can say, look, we understand. They understand the thing, and they can contribute in a particular thing, which can be the building block for space-based power. This is the situation, because I was really thinking that you have already a connection with Dr. Kalam. If you meet him,
I'm trying, sir. I'm trying.
And he was telling, I said, and then I thought he knows you, because Swaminathan was my colleague in SAC, long back, he's retired now, and he is Bangalore. But you have to do something drastic, sir. Otherwise, all your effort will go into. And I wish that it gets some recognition somewhere.
Okay.
But you have to do very aggressively. Otherwise, it will not come up. And I have a feeling the book, you should have little more technical presentation besides this. The reason is whenever you go to Chancellor Dr. APJ Abdul Kalam, he is a person who is more a technocrat. So you have to
details we are not yet got this from literature. So from these details, what is it came from JAXA or NSS also. So
He will not give you the original information because these are all classic. These are individual nations' property. And if you have to do something, you have to do some amount of research. Otherwise, launching a satellite for solar power is not a joke. And this solar power satellite, if it is to be done, it needs an equal amount of infrastructure in the ground. And for a communication satellite, it is different. But here, what happens is solar power. The moment you do it, our infrastructure should be a tandem. This and this should be together, so that from day one we should be able to see that. And once you put something wrong and there, and if there is something wrong, then the whole mission will get repaired. Is it possible to make some sort of a proto design? Because going to satellite is a big issue. It cannot. Is it not possible to have a scaled down version to make a proof of concept? Do you have a plan for it?
Because we are in detail and not gone through this.
You are basically electrical engineer?
Yeah.
So,
regarding the space and this satellite, we are not aware of this. So for that way to go to ISRO and give the they will do discussion. But we are not aware of
this
satellite and this one.
Let us assume that opening experts will do. But you have certain cost analysis. You are in electricity board. Suppose the present grid, and when it comes from a solar power thing, then what sort of infrastructure? Because we have to energize our ground systems also. What is the current cost? What will be the cost of the solar power plant? What is the instrument cost? What is the reliability? All these things you should be able to.
For that I have mentioned for cost only the equipment, what are required. But the detailed cost we are not, because we have no idea how much cost it comes. If I mention only cost in the elements, what elements it costs. The details we don't know. How to make it.
Is Maharashtra State Electricity Board, but they may not be able to take the fund because they may not be able to continue the process of research. What way you think you can contribute intellectually? Let us understand. Yes, you have done a book.
Sir, always background is that because I am facing in my organization number of problems. So I am basically my job is planner. So at present, whatever source is availability, it is not meeting the demand when the demand is going increasing. So long back, 15 years back, I heard about this space and this.
No,
So
space thing is a good thing, but implementation is a foreign task. So whatever you visualize now, it may mature in 20, 30 or even higher after that when it becomes a production. First will be a proof of concept, because then it can be a small a demonstration, a prototype. If you want to make it a production unit, then there should be a total change in the ground hardware also. Because the way you charge, the way you connect the grid, what happens if there is a disconnect? Because ultimately the quality of service to the customer has to be taken into account. Because customer will not change their home appliances, or their labs will not change their equipments because they want a power. Now, if that means, and you cannot have a special design for this, So, just. So all these things are very, very important. If you can, and even some sort of a study also gives us that what sort of impact is it. Nobody knows that if a solar power comes straight away, you cannot put it into the grid. No, it has to have a lot of challenges. No, and if I have to, if I am paying, I will demand. You cannot say, no, I am giving you a power, so whatever you can get it, because in that process, my equipment should not fail. Because I want though it is coming constant and clean, but ultimately it should give me 230 volts some current, and that is, some voltage has to come out. Unknown. And then the point is, who will take the responsibility of connecting? Because every electric now most of the places it is the private player they are doing running the show. Now the electricity board.
Private and government, both they can do this.
Like in Gujarat and Ahmedabad, it is some private fellow is doing it. In your Pune, in Bombay, I think Tata Electric may be doing something, right?
Tata and Reliance.
That's why you have to see. Let's see how it works out. So you take them to labs, and see how it works. Okay.
Multinational also you can do.
But sir, everything is okay. But if you first make your boundary condition minus infinity to plus infinity, then nothing will work. You have to cut short. If you have to say A to B, and otherwise it will not work. So, and you have to go and listen. And you see, there are big players are there, and they are very professional in this. They will not allow you to survive. And why? Because if it clicks, even if it's 2030, 2040, it will be a great achievement. So, entering into that is because this wind power, that also is working in some places, but it is not very effective, I believe, isn't it? Some places, recently I went somewhere here, there is some, I think when you go to Mahendra, you see something, right? I think the wind comes very close to your car. Some places.
Initial infrastructure we have.
And it has to be there for
And here what happens is you cannot say that I will launch a satellite and then wait for the infrastructure. Infrastructure should grow parallelly. And in fact, launching a satellite is of one complexity. Infrastructure going is another complexity, and running the infrastructure is another complexity.
So the total cost is very much.
Huge amount.
And NASA, in fact, once the advantage and afterwards they after 10 years, now they are working on that.
Because they must be seeing that there is a potential customer available outside here. See, they are not interested more outside here as well. So not, and especially in other places, where the electricity itself is, and population is very high and things like that. Anyway, thank you.
I've been there since 1977. My main activity was on power system, spacecraft power system. Then we generate solar power from solar cells, solar arrays, and when satellite goes into shadow of the Earth, we take the power from battery, recharge the battery, and DC power bus is given. And we have made satellite designs to cater to powers up to 6 kilowatts. 6 kilowatts. The life of the satellite is determined by some other elements, but over a period of time the power from the array degrades because of that whatever environment that is there. But however, we started with a meager power of 40 watts used in our area. Now our latest satellite design is 12 kilowatts. And so people have made up to 20 kilowatts big satellites. And this, I received mail from him regarding the space-based solar power. We have also seen this concept which has been proposed in many of the papers. So, this is a magnitude much bigger than what any highest power satellite so far that has been made yet. But however, the concept is a good one, and a lot of research is going on elsewhere also. So, since he showed papers also, and I requested a copy of the document you have given me now. It's very nicely prepared. I must compliment you on that. Very well compiled. Today I had to go to Ahmedabad and I got an opportunity of being here for 6-7 hours. So I just thought whether I can. So that's how I am.
He made the concept for this project in this book. So, and I try to this, study on this one, and then there is a written the books and this. So I'm trying to this project should implement in India. So for better good life for Indian people like that, and fulfill our demand like that. This is the main concept behind this. This is the global energy, worldwide energy. In 2100 years, the 55 terawatt the demand will grow. On the basis of program, I have taken this program. And in India, the demand goes near about 3 lakhs megawatt in 21-22. This is the end of the 13th plan. Sir, Harvard is he has made the concept in 1956 that the gas and this coals, these fossil fuels are going on decline like that it goes. And the graph is showing this one. In near about 20 to 14-15 years, the fossil fuels goes on decline like the seed suggested that time. The fossil fuels, the difficulties comes. Demand in several areas, the global economy exceeding ability, and the sources of generation of power are declining at a very faster rate. And it is a bad effect that the pollution and greenhouse gases, and this contributes to the global warming. So we are today getting the result in our place in Pune district. The Malani village is there. The entire land is sliding, and the whole village is entire vanished due to this global warming. This is nuclear power. This is also discharge. The main is the radioactive waste. This is harmful to life. And we have seen that in March 2011, the Fukushima, this the air. When the air blows, the power comes. This is also intermittent power. This will not fulfill the demand of this whatever required. And it depends upon the weather dependent solar energy. Now we are going to plan the solar energy ground based solar. But the ground based solar depend upon the weather dependent. And the geographic limitations are there. While some areas would benefit from terrestrial solar power, other parts of the world should receive little benefit from the current terrestrial. These are the problems in ground-based solar power. Why is the space-based solar power required? This one is the terrestrial solar power is not sufficient to meet the growing energy demand, and space-based solar power is available 24 hours. And its availability shows that this 1.316 into 10 to 9 this every square kilometer of space. This availability is here suggested. And this makes the space solar reality important to avoid all the problems of the terrestrial solar. The graph is showing that the upper one is the straight line showing that this is space solar power, and below this one is the ground-based solar. They again show the comparison between the ground-based solar power and the space-based solar power. The main is that this available 24 hours. It can meet energy requirement in 2 terms, the space constraint, and can meet the base load. what are the elements of the space-based solar power? This is a microwave technology consists of the transmitter, beam control, receiving rectifying antenna. And the other one is the DC produced by the solar panels and beams to form the microwaves. It frequency is 2.4 gigahertz from GEO orbits, that is 36,000 kilometers away from the Earth. And finally, rectifying antenna. This is the microwaves converts back into DC power. And the wireless high power transmission using microwaves in the mail forward. Experiments of 100 kilowatts transmission have been performed at Goldstone in California in 1975. Pilot project they have done.
This 2.4 gigahertz is in the S band.
Yeah.
So actually frequency coordination point of view, whether that frequency is allowed or not allowed is to be also addressed sometime or other. Which frequency is allowed, not
The
allowed.
Peter Gleason has shown that it will allow.
No, but, over the years the scenario has changed a lot. Actually frequency management, getting a frequency allocation for any particular even small communication also is now becoming an involved task. Anyway, it will have to be around this number only, but some government agency which will look after for this frequency coordinations and other frequency allotments and all, they have to get involved in clearing which frequency has to be used for this. That is one important point to be known.
This diagram is shown. This is the satellite solar panel, and this is a microwave transmission, and on the ground is a rectilinear diagram. Advantage of the space solar power: it does not emit the greenhouse gases, and it will not produce the hazardous.
The concept of this space-based satellite will be mostly it will be put in geostationary orbit,
Yeah.
orbit, where because it is directly always available. But it will twice in a year it will undergo eclipse. See what happens, it is not always 24/7 available. In the geo orbit also, 2 times in a year, that is the equinox time, that is September 23rd and March 23rd, plus minus 22 days, there will be everyday shadow, and the peak shadow comes on that equinox day, March 22nd, March 23rd and September 22nd or whatever. That duration is 72 minutes in 1 hour.
72 days.
So, and it slowly rises, day by day it will be increasing 10 minutes, 15 minutes, 40 minutes like that. And then near the 23rd March and plus minus 20 days, it will be very high, above 40 minutes. So, there will be a blackout during those periods per day.
So for that is for reliability point of view, we will put the 2 satellites there. It is
But
possible.
it is possible, but it will be, one satellite itself is so huge and so costly to build. So making 2 for the same amount of power will look something overdoing. But however, this is there. It is not always 24/7. Twice in a year.
But sir, use the amount it is okay, but it is a one-time investment.
That's right.
That cost will also recover in long period.
No, anyway, over a period, we can discuss now also. Satellite also has a limited life. Once you launch it, it will not be there for very long, maximum 15 years, 20 years, 15 years. Maybe by the time this comes, it may be like maybe 2 to 20 years. After 15 years, you will have to plan one more satellite launch. It will come. Anyway, these are the things, detailed things which we will have to work out.
You have to take care that
other one there will be blackout. The system should run.
Standby something like the hydro and other energy. Normally, when you talk about the legacy, like definitely there must be some hot standby. There are so many. It will not depending on the pull on the solar. That will not happen right now. But it may happen in let us say 40
Even if PV panels will also have a small life. Roughly at 5 years
Okay,
and
but
that
they will
will
degrade
degrade.
efficiency by somewhat 0.5% per annum.
They will degrade, their power output will come down. But satellite control will be lost even earlier than these degrade LTE. Actually what will happen is mainly you will lose ability to control the satellite. Because you need certain amount of fuel to control it. So that fuel will get exhausted. Like you are running out of petrol. So no more control will be possible.
again we have to think about the replacement of that as we move forward. But what is right now? What is in that particular India मध्ये काय होतं? What is
इंडिया
काहीच नाही. But I think I have seen particularly in Japan. त्यांनी काय प्लॅनिंग केलं किती 20 मध्ये का 32 मध्ये 35 मध्ये they are talking about the megawatt. 1 megawatt. The plan is Japan is having a plan of 1 megawatt in 2035. Is on bagawa. But let us say, do you know what is the costing of that? What is the cost of that 1 megawatt?
What cost, what we are achieving, that is the all we have.
That's why I mentioned the
Research cost will be more.
I don't know exact cost, but cost parameters I have mentioned. I don't know exact cost.
See, in spite of having found this concept way back in 1968 or so, still if it has not yet implemented, that is mainly due to cost. And anyway, others are right now available. So in future we are going to have problem.
Even you think about the solar also, no? Let us go back up to let us say 4-5 years. There we are talking about the let us say solar energy. That unit charges will go to 80 and 90 rupees. But with the let us say maybe let us say globalization, with the let us say advancement in the let us say solar panel, something like that, technology. Now today we are talking about it comes to 6 to 7 rupees within a let us say 4-5 years. So maybe technology also moving fast. Definitely the concept is good. Now thinking about the cost, maybe let us say after 5 years, maybe that cost may be reduced.
Maybe in the recent years, we may have some antenna, dish type antenna in every house, and we will pull out the energy from our domestic use. Maybe possible.
And that is also,
Yes,
when you सांगितलं, that is also very good concept. Okay, let us say now the problem is previously what is the problem? It is the cost. Now if let us say taking that particular coal and gas into consideration, that it may that day by day it is declining, the stage will come, the day will come, maybe 30-40 years, that will not be there. But at the same time, during that there may be some other replacement may be there. We are focusing on the hydro also, wind is also there. But at the same time, requirement of the user's point of view. If for example, thermals, for example, the solar, if that cost is not, let us say now, it is not, let us say, I mean, affordable, but there are the, let us say, in other countries also, there are the subsidies like this, so many factors are there, so that their government is giving, let us say, for example, some loan, interest-free loan, so that they can install. After maybe 5-10 years, most of the consumption can be accommodated with solar also. Solar wind combinations. There is so it can happen. Because it is happening there in other country. If you see the Denmark, if you see the, let us say, for example, Spain, something, it is happening.
Even in Denmark,
It is happening.
they are using the hydro, solar plus wind.
Yes.
There is one example. Recently, I met with one person on the New Zealand side. What they say is that they have the, let us say, they are generating solar and something wind, having a panel situated in the our, let us say, that premises, so they are, let us say, consuming at the same time they are including in the grid also. They are getting money of that, and sometimes within a year, they are not paying for 2-3 months. They are getting the additional, and I mean it is adjusted, and they are not paying the tariff. I mean electricity bill also.
It's a banking facility.
Banking facility. So with this, because ultimately what he says that particularly after maybe 2100, what he says that after 1500 years, our demand will grow like this, and our imagination that it will be managed by the coal and something like that. If that is declined, then it is solar. I mean space solar weather. But at the same time, with this one, maybe sometimes this may be, let us say, accommodated by the even that rooftop solar and something like that. It may happen. But this is a good concept. Only thing is that right now what you said correctly, even let us say from 60 or so, because this is now 1956. The solar concept where it is coming into long back, more than let us say 100 years. More than say 56, almost 60-70 years back. But still it is not open. That is because of the cost only. Cost and maybe some feasibility also. When let us say power is transferring that particular tower to that antenna, something like that. Future may be that you will give the solution.
Yes,
We support it.
Sir, I don't know exact cost of this project, but I putting the what parameters comes in this one. This is a launch vehicle. This is your ISRO will do this one, and the PV models this and the microwave generator, the magnetron, and the last one is the rectina. These are the instrument required for this product. Sir, these steps implementing SBSP, the consolidation of public-private participation. Role in creating awareness regarding the benefits of space. Sir, nowadays what in ground-based solar power, the silicon cells are, the size is very big and requires more space. How to this silicon cells panels to reduce and get the more power? The innovation also going on. Then now Germany has made this last this the 300 watts and the DC voltage 40 will get the maximum power. Current is 7 amperes. Will get the maximum. The main concept behind it when you put the cells in satellite, the size should be small, but more power should be generated. This is the main concept behind. The key players are in America. Solarin is there, and this PG&E, Power Gas and Electric Corporation of USA.
What are they doing? Solar in what are they doing? Startup ventures in this. They have done some work.
No, but they are the Alpha Breed is doing in America. His name is he is they are collaborated these private companies. Solarin and this Power Gas and Electric.
किती वॅटचा आहे कसं काय आहे प्रोजेक्ट?
त्यांचा प्लॅन आहे फक्त 1 गीगावॅट असं करायचं. गीगावॅट 1 गीगावॅट. हां.
What is the maturity level of wireless transmission? What is the maturity level of the technology of wireless transmission?
Sir, wireless power transmission, the Brown-Williams shows that there is no hazardness for human lives and other business. But
No,
when I discussed,
if that technology is matured enough, why we are not implementing it at the ground level?
no, sir, that's not telling that. When I discussed with Abdul Kalam sir, he told that the microwave the transmission power is the hazardous to lies on this one. He shows another wave, the nano packets and millimeter waves. On that basis, the innovation going on. The transmission of power from satellite to this one, ground. The ISRO will do this one, on this transmission power.
So I am thinking from the another angle that ground to ground transmission with wireless things.
It will, but,
If the
but
technology
the
is that
main
much mature,
ground to ground, when it is source,
then it will not require such a
the
huge
source, the
network.
main source, I don't know.
Basically, what is talking about the source point of view.
Source.
Huh? They, assuming that the coal and gas is not there, even though by having a leakage transmission with the microwave also, energy is required.
No, energy is required. We are having the energy at various pockets. We will convert it into the.
No. What he says is that this is the one, let us say, probable solution may come in future. Now today we are just talking about, we are just in the dream. From dream may definitely it will come. Huh? Otherwise, maybe let us say our next generation, they may say that. Huh?
Those are the probabilities.
Sir, 10 years back you don't know about mobile. Now mobile is now in every hand. Like that we.
I understand that.
There is a possibility of the transmission of the power through the microwaves.
The mic.
Only thing is that just thinking about the quantum. Go further, let us say, to the quantum.
The John Mankin, sir. John Mankin. He is doing the parade. His name is Alpha Parade, like that. That parade related to this private utilities.
तो क्वांटम खूप सांगितलेला किती
1 gigawatt.
1 gigawatt.
1 gigawatt किती झालं? It comes to 1000
1000 megawatt.
1000 megawatt ना 1000
1000
megawatt
megawatt.
space
Yes, yes.
हे तो हम
Sir, in Japan, JAXA is
ते करेक्ट आहे का फिगर 200 मेगावॅट आहे
200 megawatt.
हां
त्यांनी म्हटले 2035 JAXA.
I mean, 1 megawatt to power transmit करणारे they have developed that technique, but they are still experimenting on it. Might be the next project may be 200 megawatts by 2025.
तो जी एक है हमें you have to what is the cost of this 200 megawatt
Cost, I'm sorry, sir, I can't.
म्हणजे तुला मॅनेज नाही करायचं
The cost is still whenever go to ISRO, no, I will detail get.
This technology will help us. This technology will help us also. Transmitting on ground level.
Yes.
But only issue they are actually transmitting a huge amount of electrical power through microwave is a health hazard actually. Yeah. Is not yet clear. So even in microwave ovens, whatever we are doing, it is very close to this thing.
even also mobile also what today we are talking about the mobile also.
There the power is very less actually. It's a very low power.
Low power but still
We are talking of megawatts or kilowatts or gigawatts.
what I meant to say even there is a
Health
small
hazard is an important aspect. Even for communication purposes, for deep space missions, you need a very high power transmission from the ground. Okay? For example, when you send a spacecraft to Moon or Mars, because if a signal has to reach there, you have to pump a very high power there. Okay? And that high power pumping, those stations, they are called deep space networks. They are right now in US as well as even in India, in Bangalore one is there, but that antenna size is not very high, 42 meter only. There is 70 meter antenna is there in US. They have located them in Goldstone and other places where there is population is less. Okay. Because they have to, because depending on the position of the satellite, they have to pump this power in any direction. We don't know which direction the satellite will be at that time. So that much high power when they are pumping, there are safety issues. So therefore they are always they have selected a site wherein it will not affect the living beings.
one
that's why
power and what is the quantum of power? Maybe.
It is, I think, 70, it is in the order of 50 centimeter antenna is uplink power of the order of 45 kilowatts, 80 kilowatts, of that order.
80 kilowatts.
80 kilowatts of RF power.
RF power.
You have to send out. But it is not focused like this. It is a total radiation from a dish center. Okay, but however, the signal strength is high and not good for him.
Sir, in India, IIT at Thiruvananthapuram, and it is founder and another one is ISRO. Sir,
Is there any plan from the ISRO side? Something like this?
No, that's why, see, I will tell you, just now we had shown on this thing of 1400 watts per square meter is what is available from the sun. And presently the conversion efficiency of solar cells is in the order of 30%. Okay. So it means to say maximum we can get about 30% of this.
30%,
Means about 400 watts.
when we talk about the let's say ground.
No, base you can get 30%.
Base पण 30%.
Yeah.
स्पेस मध्ये पण 30% आहे का त्याचं ऑलरेडी
सोलार सेल
सोलार सेलचं नाही ना
नाही आता सध्या तरी तसं 30%
तिथे सुद्धा
तिथे सुद्धा कारण हेच पॅनल तिथे होतं
नाही असेल पण त्यावेळेस तर बिकॉज वेन इट इज हॅव्हिंग द सोलर इंटेन्सिटी विल बी हाय ना कम्पेअर विथ द ग्राउंड
हां
हां तर राईट नाव आय थिंक इथे असताना किती 20 किती म्हणतो 20 पकडतो ग्राउंड ऑफ 20 तिथे पण तेवढंच
in the solar cells, silicon was the first generation solar cells. Right now we are having what is called multi-junction solar cells. Okay, so triple junction solar cells. They have the efficiency of 30%. Silicon had 12 to 13%. So that's why in satellites we are regularly using this high power and high percentage of solar cells. They are called multi-junction solar cells, and their efficiency is of the order of 27 to 30%. Okay, state of the art. Some research is going on to further increase it also. You can predict that in another 5 years, 5 to 7 years, it may reach a figure of 40%. Products will be available, and the companies which have made these solar cells of high efficiency for space, they have also made what is called a concentrator photovoltaic cells, CPV cells. They are effectively being used for terrestrial solar plants. What they do is, they take a small size of this cell, same 30% efficiency, but they put one concentrator. Means whatever power we are receiving here, with focusing, you can increase the sun input to that small area by that magnification times that lens magnification. So that way high power is being generated, and those companies which are supplying those space solar cells, they are also making these concentrated photovoltaic cells. I think in days to come, all electricity boards and electricity whoever in charge, they should consider changing this wherever solar plants are there, from silicon to this, because you will get in the same area more power. That is a very important development which has taken place. You can just study that part. CPV cells, they are called, concentrator photovoltaic.
Cost by remaining first year can be
Cost, okay, but still you are getting 3 times more power, but not 3 times more cost.
Okay.
in other countries they are doing.
Yeah, they are selling those cells also. I have seen those plants. They are making the cells for us, The cells that we use is flat 4 by 6 or 4 by 8 size. So 4 by 8, 4 centimeter by 8 centimeter, that size cell. But they make a very small cell and concentrate with a concentrator, high input will come. The temperature will go up, so you need to do some temperature control on that particular part. But with your sun tracking on the panel and this concentration, you can generate more power.
Sir, before that, we meet to Abdul Kalam sir. We went to IIT Tiruvantapura. Mr. Das Gupta directed there. I made 2 days I stayed there, and he detailed discussed with me and told that the final decision take the Abdul Kalam sir. So, and he also for private utility and government utility for this, he told that suggested that this concept of this project will focus in different languages in India, and this will for awareness. And after his suggestion, I went to Abdul Kalam sir and we discussed with Abdul Kalam sir in half an hour, and he suggested some points like this. He firstly regret for lack of initiative from the government organization and the private agencies for this project. And he told that the finance support from government organizations, NGOs and private places for this building project. We told that the commercial approach, public-private partnership we can do that. And he told that I have suggested in this with the microwave for transmission of power. But he told that it is hazardous to lives. So instead of microwave, he told that they go to nano packets and millimeter waves. So for on this transmission of waves, I have not got the literature till today. So SPJ project has taken the international from the GSG20 countries where consortium world's leading space institutes including ISRO India and JAXA and NSS can conduct studies and research on this project. With concerned efforts especially implemented, he confidently told that with consult of this international and our this one, especially implement 20 years. He confidently told that. Sir, on 15th August, our Prime Minister Modi has he told that he has scrapped the planning commission, old planning commission, and he mentioned that dismantling the planning commission, which will be replaced by a new body called the National Development and Reforms Commission, which would have the active participation from states and whose brief would extend collaborating with the private sector. So it will boost up to the economy. So on this project, I will show the one small video.
Ecology and energy work together like two parts of a fine-tuned transmission. The sun provides us with rice, vegetables, and forests. These in turn become our food, materials for housing and building, and the fuels for cooking and heating. To grow, these plants use the carbon dioxide generated by living, breathing creatures and the various processes of life. Through photosynthesis, this CO2 is then discharged as oxygen into the atmosphere. Like humans, plants also
my main question is that how to go forward and how to get the additional literature from JAXA and NSS and ISRO. So that is my main question.
What I will do is in our library, what our sources are there, I will just go through and I will try to pass on to you. Second thing is, undoubtedly, this is, though this is not been implemented, this is not dropped also by the others. So it may be, it is still under active consideration. It can be kept under active consideration. But to implement a project of such a large scale in India, I think the path to be taken, maybe one of the best approaches would be to make a presentation to the new commission. Instead of planning commission, whatever development commission is there, they can draw experts from other fields also and make an assessment whether India should, how much India should invest from today onwards on that. Because large amount of investment is certainly needed. R&D is needed for this wireless power transmission itself. Making a satellite also is not very easy because the size is going to be very, very big. It's going to be a very big satellite. Okay, ISRO can do satellites, but this will be an order of magnitude much bigger than that. See, even with the assumption of 1400 watts per square meter, the sunlight that is available with 30% efficiency, we are having 400 watts per square meter. To get even 4 kilowatt, you need 10 square meter area. To get 40 kilowatt, you need 100 square meter area. And to get 4 megawatt, you need 1000 square meter area. That big panel you need. And you cannot launch such a big panel in one shot from any launcher. So it means to say, you should also develop a technology of building that structure there. Like such a thing has been done for the International Space Station. So what they were doing is they were sending some modules from here, and the people who are there in the space station, they will take out the other one and join it and do construction and all that. But that was all in low Earth orbit. This has to be done in the geo orbit. So transporting such big mass or such big area towards that, as even in the artist's imagination also, the size of the satellite and the antenna and the solar collector is so high that supporting too many supporting technology also have to develop parallel. So it is a question of making a firm decision and investing with a view that returns will come after 20 years. So that will be a major decision at the government level. So I think what comes to my mind is maybe a dialogue can be started.
If we start now, today, then it will come in 20 years.
Correct. That is what is going to happen. So those things are there. And from the satellite point of view also, there are many technology issues. One is building such a big one there, or transporting. I don't think it is possible to transport such a big satellite right from here in one shot. So you may have to do some transporting from here to there and again building it and all that. That is one. Second one is the control of the satellite, attitude control of the satellite is also important. If it slightly changes by 1 degree, the power collector will be here, but the power will go somewhere else. So all those things are also very important. And but we'll see what I will also discuss with my director and other things and see what can be done. But funding is another big issue. Who will fund and how it will be managed and all that. Because there are space segments as well as ground segments, and the transmission of the power from this has to be, I feel as of now it has to be planned only in remote areas, collection of this power. From there again you will have to have transmission to where people are living. So that is another.
My concept where suppose the congestion in major metro cities or this one, put the rectina there, and already grid is there. Electric grid is there in the ground.
That's right. But this RF power coming into a region where people are living is not advisable. Actually, you should think of putting these collectors in some desert area and then running the power from there to it.
And that is the only option.
Issues are there.
So you call me when we discuss our your paper, and I will come. And the main issue is how to get the literature from these people, Daksha and NSS. So from your
What is available
for your help.
I will try to share with you whatever is available. No problem. But contributions may have to come from all corners of the country for this. Or maybe, I don't know if international cooperation can be harnessed. 2-3 countries together can implement this in, so say they can make 2-3 satellites, one each on their country, but they can share the development costs.
Any more questions? Can we conclude?
Sir, a little one. Sir, can we get a little glimpse of what power-related activities are going on at your place, or something that we may have any, we should be knowing about, any research or any project, something like that? What new things are going on?
With respect to the power-related activities that are going on for the satellite, there are our source of power is again sun only, and we are converting sunlight into electricity by solar cells. And solar cells technology has improved from 12% efficiency to now 30% efficiency with the multi-junction solar cells. They are called as triple junction solar cells. And just now, as I told, they have this research was done for the sake of getting more power in space for the spacecraft, but it's spin-off.
We're getting started a little late today because very bad weather in Washington has resulted in a lot of people getting stuck in traffic, and so we didn't get here. So we're going to start about now. I think we have the other 3 participants on the phone, Dr. Alex, John Mankins, and Dr. Kalam. Is that true? Can you guys hear me? So with that, let's have some remarks from Dr. Kalam. You ready to go?
I'm ready. This is Kalam here.
Okay.
Start. You are ready?
Yes, go.
I heard the John Hopkins presentation. So in continuation, I will say that the type of experience I had in Indian Space Research Organization and also Defense Research and Development Organization, system design and system integration and system management. This is very important, and later it was a great experience for me working for India 2020 development mission with many specialists, that is transforming India into an economically developed nation another 10 years' time. When I was the President of India, one of the areas my focus was leading to world knowledge platform in critical areas for welfare of the humanity, for bringing together core competence of multiple countries. I presented to an international forum at Boston on World Space Vision 2050 how the spacefaring nation could cooperate and build on this. I discussed this with the many space organizations and experts. I have been proposing that large societal missions like bringing space solar power to Earth would need the combined efforts of nations. One day I was pleasantly surprised hear from Howard Bloom, my friend, suggesting that he would be interested in conversing with me on harvesting power from space. He told me that Edwin Aldrin has also been a great votary of space solar power. So we had a detailed interaction, and I addressed subsequently the International Space Development Conference Chicago on the subject harvesting energy from space. I suggested they may pave the way for international feasibility study. They liked the idea, and I christened it was christened in this initiative my name. I have talked to Chairman ISRO, Indian Space Research Organization, Dr. Radhakrishnan, Dr. Alex, Director ISRO Satellite Center, who is on the phone just now, and other specialists in our country. They have encouraged me to take the idea forward. I know National Space Society is quite committed to that idea. Probably our mission is to market the idea to countries so that it can move from individual society, organization to the national level initiative. I take it that Kalam is just incidental. I stand on the shoulders of all those individuals who have passion for solar power from space, such as pioneer in space solar power station like Dr. P. Glaser. So, friends, this is what I thought of introducing, and I'm willing to take any questions.
All right, since we are short on time and there's time constraints on Dr. Kalam's time, we will take questions. Dr. Kalam, the question is, will any of this be on the agenda for the upcoming summit between President Obama and Prime Minister Singh?
Well, I personally believe it's a beautiful question, and because our country is very busy in preparing for receiving your President Obama. Now, both of them, that is your President and our Prime Minister, are concerned leaders on the energy scenario of the world. They have been taking initiatives on energy independence, research, and energy missions. I have told the National Space Society to bring to the attention of the world leaders on the prospects, the challenges of solar power from space. NSA, just now, Mr. Mark Hopkins said that they are going to have an international conference in USA in May 2011. I felt that's a time we should derive the recommendation of the world body, the technical teams, and we should present to G8 and G20.
Dr. Kalam, the question is, how can space solar power help the world's poor in poor nations, such as villages in India, which particularly, I think there's a lot of villages in India which don't even have electricity currently, and there's also an issue of drinking water. So, Dr. Kalam, did you hear that question?
Well, it's a question You know, we have in India about 600,000 villages and 700 million people live there. 70% of our people have lived. And naturally, and it is a coastal region, the hilly region, and forest region, and also desert region. So this we feel by the solar power generation, you know, solar power, that all the 24 hours when you put the solar power satellite in the geosynchronous orbit, so efficiency nearly 100%. So that power, if we build a mechanism that is to transmit the power, that is the real subject of discussion. How do we transmit the power generated in space to the surfaces, in the earth surfaces? That's an area. There are many possibilities. One possibility we are discussing whether it is a microwave system or it is a laser-based system. And I have proposed what is called energy nano packages. That is an idea I have put forth. This nano packages, a power package, it can both space and earth it will move, and that's in the form of an energy package, and we can retransfer as the energy source. So these are the three aspects we have to consider the solar power transmission from the space. But after all, it's a big challenge, but definitely we have to do, particularly for India, with vast rural base and hilly region and desert region and coastal region. This type of integrated system of a solar power system and the distribution and networking, the distribution network will be one of the very important things we are going to consider in the discussion.
Dr. Kalam, the question is, what unique resources can India provide to help build space solar power satellites?
This question, unique way, India has got a core competence in designing what is called hyperplane. The hyperplane, you know, normally when the satellite launch vehicle takes off, it takes off weight to the only 2% or 3% of the payload put in the orbit. This is our hyperplane study in India has revealed we can use 15% efficiency, that is payload we can carry for 100 tons takeoff weight, about 10 to 15 tons of payload we can put in the orbit. This is what study we have made. This is because we are reusable system, and also we are collecting the air as an oxidizer, and the new technology we have proposed like Scramjet system. So India has got the capacity in design and development of a launch vehicle. For example, the reusable launch vehicle is possible, and we can cooperate with USA and other nations. And today our problem is going to be, how do you bring $20,000 per orbital kilogram? You know, now to put 1 kilogram of a spacecraft weight, that is 1 kilogram orbital weight, I call it, it costs $20,000. Now, for solar power satellite success, we need a launch vehicle system which can put number of times we can reuse it, and also the type of cost it will bring down from $20,000 at least $2,000 per orbital kilogram. So this is India can cooperate. You know, in India we have one of the technology, we always have certain experience with at low cost access to the space is possible. So this experience India can share with the nations, other spacefaring nations.
Next question.
Next question.
Next question. Next question is, where would the funding be coming from for space solar power satellites?
Well, funding, that is, we have to see that, we have to market. First of all, we have to market that how you are getting in the carbon neutral system. That is, today, the citizens of Earth, 6 billion people, we have taken away whatever possible from Earth. Now you have to regenerate the Earth. That means we have to make at least now from fossil fuel, we have to graduate. Already big movement going on USA and India to graduate from fossil fuel to renewable energy system. So the question is whether terrestrial renewable system or space solar system. Space solar system has got an advantage, all the 24 hours Earth and irradiance available and the energy available. And indeed, terrestrial solar power is a promising area for the future. However, it has a limitation, terrestrial solar power. First, the level of solar irradiance is about 1.5 times in the extraterrestrial level than at the surface of the Earth. Second, in case of surface-based solar power plant, the panel can collect solar power about for only 8 to 10 hours a day. That means as long as sun shines. Whereas, in the case of space-based solar power plant, the collection time is full 24 hours. Also, the space-based solar power plants are not affected by weather conditions, which may bring down the efficiency in case of terrestrial power plant. Hence, I believe with this advantage of solar power satellites, the conference what we are going to have in USA in the middle of the next year, definitely we have to market this idea to the political system of various countries. We have to market it. After all, any system we want to achieve with advantage, because our marketing trend should be, advantage should be, how do we make the Earth livable for more than 6 billion people? That is carbon-free from the fossil fuel. How do you graduate from fossil fuel to solar power? That is the marketing point for technical and scientific people, and to how to market to the political system. I can help people in that area.
The last question, Dr. Kalam, is to what extent have you thought about integrating space solar power into the solar activities which are currently going on in India with regards to ground-based solar?
The National Solar Mission.
Specifically, the National Solar Mission.
Yes. India has solar power mission, terrestrial solar power mission. By 2020, they want to generate 20,000 megawatt power. And by 2050, they want to go 50,000 megawatt power. But my feeling is our demand is is going to increase because of the industrial activities and agriculture activities and service sector activities. So we need the energy, extra energy sources. I think solar power satellites will meet the requirement not only India and USA and many other countries.
All right, thank you, Dr. Kalam. We're going to move on to our other speakers. You can leave now or stay for the rest of the conference, which will be about a half hour. John Mankins, are you on the phone? Next slide.
Yes, I'm here.
Okay, let me introduce you. John Mankins was Chief of the Operating Officer at Managed Energy Technologies. That's his current company. He's also president of Space Power Association, which is a nonprofit organization. He had a 25-year career at NASA. At one point at NASA, he was running an $800 million per year R&D program. But the two most important points are the ones at the bottom. For many years, he was in charge of space solar power activities and research at NASA. And today is the world's leading expert on space solar power. So, John, please go forward.
Okay, good morning. I'm sorry that I'm not able to be there at the press conference in D.C. I'm actually out in California, where it is a beautiful dawn just starting here. I'd like to just comment on this dialogue between India and the U.S. It actually goes back a number of years, in fact, over a decade, in thinking at the working level about the prospects for both the two nations and for the world in developing the capability to deliver power, solar power from space, pretty much anywhere on the planet and on demand. And this idea has been discussed both in a series of preliminary meetings over time involving the two countries as well as others, and has, as Mark Hopkins mentioned in the first part of the press conference, matured into this idea, which is embodied in the Kalam National Space Society Space Solar Power Initiative, to try to organize a systems-level end-to-end study as well as preliminary workshops and meetings on the topic of space solar power. I think one of the critical things to keep in mind regarding this capability is that it has enormous promise to deliver power globally, power that would be a very green, very low carbon footprint, but also that we're not quite ready to do it yet, and that both further design and definition studies are needed, as well as the maturation, the development, the demonstration of key technologies, including things like wireless power transmission, which President Kalam was mentioning a few minutes ago, and other technologies related to lowering the mass of spacecraft systems, reducing their cost, and enabling the in-space assembly and deployment of these exceptionally large spacecraft concepts. So on the one hand, this is a concept. Space solar power is a concept which holds enormous promise, as great or greater than the promise which is often ascribed to fusion energy in the future. And it has some remaining technical challenges. Obviously, we're not ready to begin full-scale development at this moment. But having said both of those things, one, it's great promise, and two, its need for further development, I would just close my remarks by saying that there has been an ongoing assessment of this concept for the last several years by the International Academy of Astronautics, and in the spring, hopefully that report will be coming out, and it will provide a backdrop for the ongoing studies, workshops, and discussions, and hopefully research and development as we go forward next year. So that's it for my opening.
John, I think this is a question that you best can answer. What cost estimates currently exist for accomplishing the space solar power concept?
The last thorough end-to-end system studies that led to what I would characterize as rigorous cost analysis go back to the mid-1990s. It's been a number of years since there's been a good end-to-end systems analysis. I can indicate, and that's one of the things that we're advocating now is needed at this time. I can tell you that the requirement, what the goal is in terms of research and development in the field, is to target the goal of 10 cents per kilowatt hour, and essentially this translates into three high-level characteristics that an economically viable space solar power system would have to have, and that is that the mass of the platform in space would need to be roughly or not more than 3 kilograms per kilowatt of power delivered, that the cost, the deployed cost of that system in space would need to be not more than, or approximately $3,000 per kilogram, and that translates into essentially an installed cost of about $10 per watt for space solar power, and that the operational lifetime of the system, of any particular system element, would need to be at least 15 or 20 years. And if you translate those things forward, what you end up with parametrically is a goal of about 10 cents per kilowatt hour, which would allow space solar power to be highly competitive with other available alternatives for green energy terrestrially.
Oh, you're still on, Dr. Kalam?
Yeah, I'm there.
Okay.
I'm there. What Alex answered about the GDP, R&D GDP in India, I would like to add that whatever he said, it works out to 2.5% of our GDP for R&D, 2.5% of the GDP. That's what we are spending.
Okay. Dr. Kalam, the question is, what's the earliest reasonable date at which space solar power might be available?
Well, I personally believe it is a project of about 15 years project, and I have suggested 3-phase studies, and the first 50-year some sort of a prototype will come in the launch vehicle and also in the space solar power. At 10th year, some sort of trials and testing. 15 years, I believe it is a 15-year project and international project. It is not all the spacefaring nations have to be the partner, and their best core competence has been shared. For example, India's core competence, cost-effective systems, and also certain unique technology of the propulsion, and also now we are working on the electronic system, and we can share country to country, and so that synergic effect will come. It should be an integrated program of multi-nations, and we have to share. Some countries should develop the reusable technology, some countries should develop nanotechnology for solar power panel, some countries should develop the integration of the multiple systems. So I believe it is probably we can discuss in the solar power conference which is scheduled this issue of which are the countries which can take up what type of task.
Let's handle one at a time. Okay. John, the question is NASA aware of this initiative, and are they likely to get on board, or what's your opinion about that?
In terms of whether or not they are familiar with the current Kalam NSS and Space Solar Power Initiative, they're certainly aware of the ongoing dialogue and the discussions that have involved India. As I said, they've go back several years. I have not personally briefed them on this topic, so I don't know if they're aware of the initiative which is being announced today. I think in my past, in recent discussions with NASA, their emphasis, of course, has been increasingly during the past year in light of the President's 2011 budget on developing fundamentally new and transformational capabilities for space exploration, science, development, including a range of new advanced concept studies and things like game-changing technology development under the auspices of the new chief technologist, Bobby Braun. I think that depending on how it was undertaken, that there's a good chance that NASA would certainly support relevant technology developments. But in terms of a policy-level initiative, I think that would have to come through channels. I don't think that NASA would of its own accord initiate new policy activities with regard to international relations between the U.S. and India. That's the kind of thing that NASA is typically, they follow the lead from other policy formulation agencies in the White House or State Department. They don't. Thank you.
This is Kalam here. Mr. Mark Hopkins, Kalam here.
Yes, go ahead.
You know what Alex answered and what John Mankins answered. I want to convey to the friends who are assembled there the one important point. The solar power satellite is the way, by solar power satellite, how the planet Earth will be a clean planet, prosperous planet, and the happy planet. This has to be an international effort with multiple stakeholders. All our difference will get minimized with space leadership and participation from G8, G20 country leaders. Instead of Cold War and conflict, we need to move towards warmth of international compassion for better planet Earth. That means we are going to regenerate the planet Earth through solar power satellite. That's the point I would like to convey.
Okay, the question is, and maybe John Mankins would be best to answer this, is how does this concept of solar power sent down to the Earth compared with solar power which is collected on the moon and then transmitted down to the Earth? John? John, can you hear me?
Yes, I can hear you fine. Sorry, I had the mute on. This is a very interesting question and one that's been looked at repeatedly over the last 25 years. This idea was originally formulated by Dr. Dave Criswell at the University of Houston. I think ultimately the moon or other extraterrestrial sources, resource sites are very, very promising in terms of their potential to provide materiel, both logistics and hardware, to future space solar power industries. However, I think that there are some very fundamental physical challenges in trying to deliver power directly from the lunar surface to the Earth, not least of which is the fact that the moon is about 10 times further away than geostationary Earth orbit. This makes the delivery of power not 10 times more difficult, but 100 times more difficult because of the physics of the power transmission systems. Also, the fact that the moon is only in one portion of the sky over the Earth at any given time means that a system of relay satellites or ground-based infrastructure, huge ground-based infrastructure, would be necessary to use the moon for substantial amounts of power. Those are just two of the principal challenges. There are a number of others. But ultimately, I think the moon and other bodies could certainly play a tremendous role in the future development of space, including space solar power. But I think that the argument at this time is largely against the use of the moon as a platform from which to deliver power directly to the Earth.
John, maybe you should take this one. The question is, what sort of, at this conference that we're doing in May, what sort of technology dialogue do you think might occur and might come out of that? Specifically, what was your example?
Well, the question was what the goals were for the conference and what level of technical detail we could get into without running afoul of experts.
Okay. What are the goals in a technical sense for this conference, and how much discussion can we do given the export constraints that the United States have, like ITAR?
Sorry, Mark. Obviously there are going to be limitations to what we can do in any kind of initial discussion, but I think what can be anticipated if the proposal for this meeting is approved is that there will be a series of pre-prepared papers, very much like at a technical symposium, or it's a technical symposium organized around the technical challenges involved in space solar power. Those papers can be prepared ahead of time and can be reviewed and cleared by the respective organizations, so that we are within the bounds, obviously, of ITAR restrictions. And then we can begin essentially the preliminary discussion on issues related to the programmatics, how we might organize future studies, how we might coordinate future technology activities, without getting into the in any depth in this initial meeting on the details of.
John, why don't you take this one too? The question is, what would be a typical size for a prototype for space solar power?
Well, I was challenged on this a couple of years ago after the National Security Space Office did their study back in 2007 by Joe Rouge, who was at that time the incoming director of the NSSO. Basically, what's something that's digestible and tractable? And the outcome, just trying to think about this, that I came to, and I don't think that there's one answer to this, but I believe that a reasonable solution is something for a prototype, not for an full-scale operational system, would be something that was roughly 10-10-10, i.e. a platform which would be a real working prototype that could deliver something on the order, not exactly, but on the order of 10 megawatts, that would cost less than $10 billion to develop as a prototype, a working prototype, and which would take less than 10 years to accomplish. So 10 megawatts, $10 billion, and 10 years. More than 10 megawatts or so, less than $10 billion, and less than 10 years. I think that would make a truly significant accomplishment, and one that would establish not only the technological feasibility, but also the real economics of space solar power.
Okay, that was the last question. Dr. Kalam, would you like to make some closing remarks? Dr. Kalam, can you hear me?
Well, I have, I believe for the growing population of the world, the power situation is a matter of concern. Energy independence, that is, energy independence means free from fossil fuel, has to become a goal not just for individual countries but to the entire world. And new technologies like nano and the integration of bionode information knocking at our doors. Worldwide, there are also human resource constraints and budget constraints. This is why it becomes relevant for countries to come together on a common platform for a mission synergizing the core competencies. So I have recommended formation of World Knowledge Platform. World Knowledge Platform is my proposal to bring together all the spacefaring nations with core competencies identified. The mission for World Knowledge Platform will be solar power satellite. That is what I would like to say. Then another area, open source space solar solution sharing platform, I am recommending. Open source space solar solution sharing platform. A lot of young people from the world, they can come and start critical technologies for solar power satellite. These are two of my recommendations.
All right, let's have a big hand for all of our participants. And that'll be it for today. Particularly, I'd like to thank Dr. Kalam and Alex and John for their participation. You can drop off now. They're going to. We've run up to 11 o'clock. We've got another 3 minutes. That's when they sort of throw us out of this room.